Welcome back to the channel, everyone. Today, we're starting a new series all about motor starters. Have you ever wondered why motors need a starter or what could happen if you don't use one? Stick around, and I'll break it all down for you. In today's video, I'll be giving a general introduction to motor starters, why they're essential, how they work, and the different types you can use. In the next videos, we'll dive into each type, starting with the DOL starter. If you're excited to learn about motor control systems, hit the like button, and don't forget to subscribe so you don't miss the upcoming videos. Motor startup conditions. When a motor starts, it's stationary, meaning there's no back EMF yet to regulate the current. Equation: V equals sign E underscore B plus I underscore A asterisk R underscore A, where V is the applied voltage, E underscore B is the back EMF, I underscore A is the armature current, R underscore A is the armature resistance. At startup, the motor doesn't have any back EMF, E underscore B equals sign 0, so the current, I underscore A, is only limited by the armature resistance, R underscore A, which is very small. This means the starting current can be very high, and that's a big problem. Consequences of high starting current: sparking and damage. High current causes sparking at the brushes and can destroy the commutator. Mechanical stress. It also creates a large torque, which puts a mechanical shock on the motor shaft, reducing its lifespan. Electrical overload. The motor may draw too much current from the supply, which can trip breakers or damage the supply system. Starters for induction motors. Induction motors and starting current. For a three-phase induction motor, the rotating magnetic field makes the motor self-starting, but it also creates a problem. The motor tends to draw very high current at startup. High current at startup. This current can be 6 to 8 times the motor's full load current, which can cause serious damage to the motor windings if it's not controlled. Why a starter is necessary? To avoid damaging the motor and other connected equipment, a starter is used to reduce the initial current by lowering the supply voltage during startup. How induction motors work at startup. Induced EMF and slip. At startup, the slip in an induction motor is maximum. This means the rotor experiences the maximum induced EMF, which leads to a high rotor current. Motor acts as a transformer. In this state, the motor behaves like a transformer with a short-circuited secondary winding, essentially causing very high current in the rotor and consequently in the stator. Current drawn by the stator. The stator draws a current of 5 to 8 times the full load current, making it crucial to use a starter to limit this inrush current. The need for starters. External resistance. For most motors, we use external resistance in the armature circuit to limit the starting current. This is particularly important for motors above fractional kilowatt ratings. Variable voltage systems. In some cases, where variable voltage is available, you can control the starting current by applying low voltage at startup, avoiding the need for starting resistances. Real-life example: onboard ship. Onboard ships, where power is provided by diesel generators, starting large motors without a starter can cause the generator to trip due to the large inrush current. Advantages of using starters. Smooth start and stop. Starters ensure that the motor starts and stops smoothly, preventing any sudden jerks or mechanical shocks. Limiting starting current. They limit the starting current to a safe value, preventing overload on the motor and the power supply. Protecting the motor and power supply. Starters monitor the motor's running current and offer protection against overload, undervoltage, and other harmful conditions. Safety for connected equipment. They also help protect generators and other equipment from being damaged by high starting currents. Types of starters. Hardwired starters, DOL, direct online. Starter. This is the simplest type of starter. It applies full voltage directly to the motor but is only suitable for smaller motors. Star delta starter. This reduces the voltage at startup by starting the motor in a star configuration and then switching to delta once the motor has reached a certain speed. Auto transformer starter. This reduces the voltage during startup through an auto transformer, which limits the inrush current. Electronic starters. Soft starter. A soft starter gradually increases the motor's voltage, ensuring a smooth start with limited current. Variable frequency drive, VFD. A VFD provides even more control by adjusting both the voltage and frequency, allowing for precise control of the motor's speed and torque. So today we learned why motor starters are essential. They protect the motor, the supply system, and connected equipment from the harmful effects of high starting current. In the next video, we'll take a closer look at the DOL, direct online starter, how it works, and when you should use it. Don't forget to subscribe so you don't miss it. If you found this video helpful, make sure to like, share, and comment with any questions you have. See you in the next video.